And our final question in our 8-1 chapter practice test, it says a jar contains equal numbers of nickels and dimes. The total value of coins is $4.05. How many coins are in the jar? Now, speaking to the Kennedy effect, it's very difficult to figure out what we want our variable to represent and what we have to create. But we're going to always start with an x and see if we can build upon that. So we're going to make x, since there are equal numbers, we're going to make it the number of nickels or and dimes, because they're both the same. So x is going to represent the number of each of the coins. But we're not given numbers, we're given values. So that expression only works for the number of coins, not the value. So if we modify that variable to be values, we can say that this will equal the value of the nickels, and this, multiplying the number of dimes by 10 cents, will equal the value of the dimes. All right? So now we have the value of the nickels is that, the value of the dimes is that, and together, these two expressions equal $4.05, and we're going to create that. So we're going to say all of the dimes plus, or sorry, all of the nickels plus all of the dimes will equal $4.05. So now that we have this equation, just like we did before, we're going to simplify this side because this is not technically simplified. We can make it into 0.15x because we can gather like terms. And now we have this beautiful expression that looks exactly, or equation that looks like all the other ones we've done. Divide by the coefficient. The value of x will equal $4.05 divided by 0.15, 27. So what does that mean? That means there are 27 dimes and there are 27 nickels. You don't have to. You just have to say how many coins are in the jar. There's 27 dimes and 20. Yeah, sorry, you do. I like your hair. Very nice. So therefore, there are 54 total coins. Because there's 27 nickels and 27 dimes. Our variation of this particular question is really interesting because it says a jar contains a mixture of dimes and nickels worth a total of $4.75. Now, different than the first question, they aren't the same number of coins. There are 3 times as many nickels as dimes. So the first thing we have to do is figure out, okay, x can't represent the number of nickels and dimes because they're different. But x can represent the number of dimes. And since there are 3 times as many nickels, 3x is going to represent the number of nickels. That's our first step. But again, just like the last time, we're not given numbers, we're given value. So just because I know the numbers doesn't mean I know the value. So I have to change these expressions to represent value. So therefore, the value of all the dimes will be taking the dime value, or 10 cents, and multiplying it by the number of dimes. And the other expression will take the value of a nickel, multiplying it by the number of nickels. So these two expressions will represent the value of each of those coins. But when we look at this one, what do we realize that's not done with this one? It's not simplified, right? We can actually multiply that 3x by 0.05. So we can say instead 0.15x. Okay, so instead of this expression, I'm going to use 0.15x to represent the value of the nickels, because I'm just multiplying 3x by 0.05, or combining the coefficients. So the value of the dimes plus the value of the nickels equals 475. Those are not combined, so we're going to combine those into 0.25x equals 475. Divide both sides by my coefficient. And 475, how many quarters are there in 475? 475 divided into quarters. There are 19 quarters in 475, so therefore, x equals 19, but we're not done. How many dimes are there? 19. Oh, it doesn't ask for how many nickels are there. Okay, if there did, how many nickels would there be? There'd be 60 minus 3, which is 57. There'd be 57 nickels and 19 times.